Hello everybody. Since I'm not able to be there today to help you out, I'm making this video to give you some instructions on some new things that we need to do. The last two meetings we made a lot of progress on our attachments. Hopefully we are ready to put them into action soon. This time we should spend a lot more time programming the robot to get into position to use the attachments. This will be our biggest challenge and probably our main activity from here until the tournament. In order to accomplish this, we need to remember how to do programming tasks, like using the gyro sensor to travel in a straight line and make turns, and using the color sensor to detect and follow lines. The good news is that this week we got a second color sensor, which will enable us to align or square the robot. Today we're going to learn the new task of aligning the robot on a black line so that it is perpendicular to the line. Alright, you'll have to bear with me as I'm moving the camera around. Alright, the robot is unchanged for the most part from last time. And you can see that there are now two color sensors. And they're placed in approximately the same position, and one is paired with each wheel. Now if you look at it really carefully, the positioning of each one is not exactly the same as the other. And this is what we're learning about Legos, is that these are sophisticated pieces of equipment, but they're not perfectly exact in every last little thing. And so we're going to have to learn how to deal with that. These color sensors, when they're in reflected light mode, will shine a red light on the surface, and that light is reflected back into the sensor. Now you notice if you look at the two of them, that the two red circles, they're not exactly the same size. That means one's a little bit higher off the ground than the other, and the positioning relative to the robot is a little bit off. And so, these are issues we have to deal with as we're programming the robot. Alright, I've set up our floor here with a black line for us to detect and square. Let's take a look at some pseudocode that I have developed for this task. Alright, the first thing we want to do is run the wheel motors on two simultaneous programs. On each program, have a wait for block detect the dark line using the color sensor paired with each wheel. So let's take a look at how that's going to work on the robot. We have two wheels, one connected to the B motor, one connected to the C motor, and then we have two color sensors. One is in port 1, one is in port 4. So you need to remember those pairings. B goes with 1, C goes with 4. That's important. Okay, when I say two simultaneous programs, I'm not talking about anything too complicated, but we just want to have two different large motor blocks. You hook them both up to the start by the use of cords. That way they run at the same time and they don't really interact with each other. First thing to remember is we want this to be on, not on for rotations or on for seconds. Alright, they're both going at the same speed, 50 forward. We also need to make sure we have the right motor selected. So B and C. So now they're both going forward. Now we need to wait for, continue that action, in other words, until the color sensor picks up the black line. So let's take a look. Color sensor, compare reflected light intensity. And we'll do that the same with the other block. So color sensor, compare reflected light intensity. Make sure, this is very important, that you have the correct ports on here. Port 1 goes with motor B, and port 4 goes with motor C. So far, so good. Alright, now the question is, what are we looking for? What is the line looking for? Or what is the color sensor looking for when it's detecting the line? Alright, so take a look at the second line of our pseudo-code. Stop the motors individually when each color sensor detects the black line. Use live sensor readings to find the right value for each sensor. Remember, we said that the positioning of the sensors is not perfect. And so we need to take some live sensor readings in order to see how that's going to work. Alright, so first of all, we're dealing with a wood floor here, not a white table. And so the wood floor is going to have a lower value than a white table would. And then the black line here we've set up, we're going to make this like partway on the black line here. Alright, so that seems about square. Let's go back to the computer and see what click this little icon over here, see what our sensor readings are. Alright, so here's what I'm talking about. The color sensor in port 1 is showing 11, and the color sensor in port 4 is showing 17. So we have a 6 degree, or a 6 value difference between those two readings. So we want to treat them individually. Alright, so for motor B, we want a value that's less than, let's not do 11, let's do less than 15. And if that's the case, then we'll say stop the motor. Make sure you specify which motor to stop, B. Alright, for motor C, let's say less than 20. Doesn't have to be exact, but that's about how far apart they are. So if less than 20, we're going to turn that motor off. Make sure you specify which motor, C. Alright, let's save project as align 2. I've already done align 1. Let's do align 2. Alright, let's go ahead and run our program and see if it works. So here we go. Alright, it stopped Both motors stopped. You notice that it's not exactly perfectly aligned, is it? So we'll need some more work. Now let's try it from an angle. See how well it does with that. That didn't work well at all. Try it again. There we go. Now you see that it hit one corner first and the other motor kept going until it's lined up. But again, not lined up perfectly. Do one more test. We'll have it come from this direction. See, no matter which way you're coming at it, it'll keep going with the other motor until it's more or less square. Now, a couple of problems. First of all, we notice that it's not perfectly square. We would like to be more square. And it's over the black line. It's shot past the black line because of momentum. When you say motor stop, it doesn't stop exactly the place where you say it. Because of momentum, it keeps going a little bit further. And that's going to vary depending on whether you're straight on the line, how fast the robot is running, and so forth. So we want to fix that somehow. So let's see what to do next. Take a look at our pseudocode. Okay. The third item says the robot may or may not have drifted forward somewhat, so we need to back up and find the very darkest part of the line, with each sensor. In order that it does not drift any more, this next part should take place at very slow speed. So let's run both motors forward at slow speed for a small distance to make sure the robot clears the black line. So we're over the black line now, but what if another situation we end up being more or less on on top of it? So we need to fix that. Alright, we're going to follow, we can't follow both of these programs, so we're just going to follow one of the programs. It doesn't really matter which one. But we're going to say go forward at a speed of 5, nice and slow. And we're going to do it for rotations. We'll do it for 0.25 rotations. So it goes forward just a little bit. Alright, back to our pseudocode. Now it says run one motor backwards at a slow speed until the color sensor detects a value that represents the darkest part of the line. Theoretically that is close to 0, but you have to do live testing to find out for sure. So we'll use our same values. And then repeat with the other motor until you get the same value. So we'll square up one side and then square up the other side. Alright, so once again, large motor. I made a big mistake here. Look at that. I didn't want to move one motor, I want to move two motors. So instead we'll do the move steering block. Alright, so forward at speed of 5 instead of 50 for 0.25 rotations. Now we see that's B and C, so we're good there. Alright, now we can add to one motor. We'll do B first. And we're going to say speed of -5. So we're going to go backward at a very slow speed. We don't want to do it for rotations, we want to do on. Let's scoot everything over so we have room. And then we're going to once again use the wait for block. I'm going to wait for color sensor, compare reflected light intensity, and less than 15. And then we will stop that motor. The port 1 is already correct, so we're good there. Motor off. Which motor? Motor B. Alright, that wheel is done. Now let's do the other wheel. This time it's wheel C. We're going to go -5 backwards. Not for rotations, but just on. We're going to wait for color sensor, compare reflected light intensity, but make sure this time it's port 4, since we're doing the other wheel, and we want it to be less than 20. Because remember, that's the value over here that we discovered for the other color sensor. Alright, and then we will stop that motor. And then hopefully at that point we will be more or less aligned. Let's save this and see if this whole thing works. Alright, ready, set, go. One other thing I think that we need is one more wait for block. We need to wait for both of these motors to come to a standstill before we move on. I'm going to say that takes a half a second. So 0.5. Let's see if that works. Here we go. It's moving forward. Now it's moving back one wheel. Moving back the other wheel. We should be square now. Boy, that's pretty square. I think for our robot that's pretty darn good. Now let's see what happens if it approaches the line at an angle. See if it will still work. Ooh, it ran into something bad. I'm thinking it might have seen one of these lines on the floor and didn't like it. Let's try it again. Oh. It overshot that line. I positioned it poorly. And so the sensor went right past the line here. Try it again. There we go. Alright, that looks pretty good. Let's try it from the other angle. Let's see if that works that way. Okay, so there are other sophisticated things you can do, but this I think will have to be good enough for our purposes since we have not a lot of time left. Other factors you'll have to take into account are on the table. We have different colors because sometimes there's a black line and a white line on next to a white area, but not always. Sometimes it's next to a green or like a brown area, and so you'll have to do different types of testing. You may decide that you don't like how slowly it's taking to square up to the line, and so you may say, well, I don't want it to go 5, let's try doing it at 10, because it's just taking too long to align. So there's various things like that you can do with this program to enhance it for your purposes. Alright, so let's say 10 minus 10 minus 10, oops, minus 10, there we go. See if you like that any better. Alright, so that took like 2 or 3 seconds to align. Out of 2 minutes and 30 seconds, that's not so bad. And it'll be worth it if the robot then finds the target instead of crashing into the wall or crashing into one of the objects, and the ref has to stop our robot and award us a penalty marker. Alright, that's all. Feel free to refer back to this video. I know it's a really long video, but you can refer back to it to look at the code or the pseudo-code, just sort of by moving around the various parts of the video, so you can figure out what to do when you're programming for your mission.